This is the experiment to measure the acceleration of freefall. Sometimes it's called the falling bodies apparatus. This ball bearing is the falling body. It's falling under the influence of gravity. We're neglecting the effects of air resistance in this experiment. At the top here we have an electromagnet. That is a ball bearing suspended from the electromagnet. That is connected to the timer, so when I switch off the electromagnet, the timer will start. So that's the time when the ball bearing will start to fall. At the bottom is a trapdoor, and that is also connected to the timer, so when the trapdoor opens, because the ball hits it, the timer will stop. That will then provide me with the time taken to fall this distance here. So that would be one measurement. I measure the height from the bottom of the ball bearing, which is what hits the trapdoor, to the top of the trapdoor, and I measure with a meter rule. Having taken the measurement already, I know that that's 60.3 centimetres. I'm going to write that up here, 60.3 centimetres. Of course, I need to convert that into an SI unit, so that will be 0.603 metres. I'm going to make sure the timer is reset, and I'm going to now switch the electromagnet off so I can get a measurement for the time. I'm only going to do this one. Ordinarily, to be more accurate, we would repeat. So that's 0.365 seconds. I know one other quantity here, which is the initial velocity. The ball bearing starts off at rest, so U is equal to 0. I can now do a simple calculation with that to find the acceleration of freefall. Let's move this to the side. This is the displacement of the ball, this is the time taken, this is the initial velocity. So I can use this equation where I'm trying to calculate A. The first simplification I can do is that because U is 0, this whole term is 0. So that's 0. And now I rearrange it for A. 2 times s over t squared. I substitute my values in, so that's 2 times 0.603 divided by t squared, which is 0.365 all squared. And when I calculate that, I'll get my value. That's going to be probably less than g, and that would be due to the limitations of the experiment. So the limitations of the experiment, which are also required knowledge, are obviously we discounted the effect of drag, but there is drag, and therefore that will affect the experiment. So that's the first limitation, drag, the presence of air resistance, or drag you can say. A sticky magnet. And what we mean by that is that because it takes a very small amount of time, but some time nonetheless for the magnetic field of the electromagnet to collapse, the ball bearing will not instantly begin to fall. So there's a little bit of a delay there, and that needs to be factored in. And then the final one is that when the ball hits the trapdoor may not instantly open and therefore stop the timer. So there's also a small amount of delay there. And so that causes our value for G to be less than the value 9.8 meters per second squared.